In this video, we're going to talk a little bit more about the type 1 and type 2 errors. So first, let's look at the definition. A type 1 error is rejecting H0 when H0 is true. Now, the type 2 error is kind of the opposite of that. It would be failing to reject H0 when H0 is false. Now, that's a little confusing because of the double negative, so I'm using the word accepting here. And now it's a little more clear. Accepting H0 when H0 is false. That would be the type 2 error. So notice these are two different types of errors. They're not the same error. Okay? So one is rejecting H0 when H0 is true. Okay, if it's true, you shouldn't reject it. The other one is accepting H0 when H0 is false. Okay, so if it's false, you shouldn't accept it, right? So those are both errors, and they're different errors. Okay, so let's look at what this means in terms of the shark example from the last video. So what we were testing to see is if the sharks off the coast of Bermuda were longer than the average great white shark. So the average great white shark was 21 feet. And so the null hypothesis, so H0 here, assumes that there is no difference, that the average of the great white shark is equal to 21, the average of the sharks off the coast of Bermuda are equal to 21 feet. So the null assumes that the hypothesized mean is true, okay? So 21 feet is the hypothesized mean. The null assumes that that's true. Okay, and we want to see, do I have enough evidence to reject that in favor of the alternative, which says that the true mean is greater than 21 feet. Okay, so notice, in order to conclude the alternative, I have to reject H0. So when I talk about rejecting H0, when H0 is true, I'm not rejecting what it is I want to show. So that makes it a little confusing here. So in other words, I have to reject H0 in order to show that the sharks are really longer, right? So the type 1 error, rejecting H0 when H0 is really true. So you're rejecting H0, concluding the alternative when H0 is really true. So this would be concluding that the sharks are longer when in fact they're not. Okay? That would be the example in this test of what the type 1 error would be. Concluding that the sharks are longer when in fact they're really not. Okay? So the type 2 error here, it's accepting H0. Okay? So in other words, I don't reject this and conclude the alternative. I accept the null hypothesis, but really the null hypothesis is false and I should have concluded the alternative. Okay? So the way you would state the type 2 error would be not concluding that the sharks are longer when in fact they really are longer. Okay? So in other words, you don't reject H0 and conclude the alternative, but really the alternative was true. Okay? You should have rejected H0. That would be the type 2 error. Okay? So those are the two types of errors. So type 1 error is rejecting H0 when H0 is true, which means you're concluding that the sharks are longer when in fact they're not. And then the type 2 error would be accepting H0 when H0 is false. So you're not concluding that they're longer when in fact they really are. Okay? So this is, it takes some thought. You really got to pick this apart for yourself to really fully understand it. One thing that may help is that in criminal trial in America, we always assume someone's innocent until proven guilty. Okay? And so what we're doing, the null hypothesis is that they're innocent, and we're looking at the evidence to see if there's enough evidence to reject the null in favor of the alternative hypothesis, which is that they're guilty. Okay? And so the type 1 error would be rejecting their innocence and concluding they're guilty when in fact they're innocent. So the type 1 error is condemning an innocent person. Okay? The type 2 error would be accepting their innocence when in fact they're guilty. So this would be acquitting a guilty person. That's another way to think about this. Okay? Type 1 error is condemning an innocent person, which you don't want to do. right? You really don't want to do that. And then type 2 error is acquitting a guilty person. Also an error, okay? But this error seems worse. It seems worse to condemn an innocent person, okay? So that may help you think through these. Now, it's important to understand these two types of errors, and that you always kind of run a risk of committing one of the errors. So when you actually look at the results of your test, you can kind of weigh the results and come up with a good interpretation, a good conclusion for what your test is telling you. Now, to fully understand this, it's important to understand that the probability of committing the type 1 error is equal to alpha, okay? And so you can kind of see this with the shark example, okay? We had enough evidence to reject it at the 0.05 significance level. So my critical value was 1.645, and the test statistic was like 2.04, and so it fell into the rejection region. We rejected H naught, okay? And we're probably making the right decision here because the probability of being wrong is only 5%. That means I have a 95% chance of being right, okay? But I do run the risk of committing the type 1 error. Whenever you reject H naught, you run the risk of committing that error, okay? Doesn't mean that you've committed it. In fact, you're much more likely, it's much more likely that you're not committing the error, because alpha is the probability of committing the error, and that's a low probability, okay? But if it's very important that you don't commit the error, then you want a smaller alpha level, right? You want your alpha, you want the probability of committing the error to be less. So at a 0.01 significance level, what that actually did is it moved your critical value further out, making it harder to reject. Okay, basically like what it says down here, if H naught is true, then you would expect your test statistic to be close to 0. That means the further out the test statistic lies, the more evidence you have to reject H naught. Okay, here it doesn't require the test statistic to go out as far, so it's easier to reject. Okay, but here you got to go all the way beyond that, and in our shark example, 2.04 did not go into the rejection region at the 0.01 significance level. Okay, and so you failed to reject H naught. So that's the idea here. Your alpha is the probability of committing a type 1 error, and if you really want to make sure that you don't commit it, then it's good to be able to reject at a smaller alpha level. In fact, when you reject at a smaller alpha level, then we would say that the results are more significant in that case. Okay? One way to think about this too is that, you know, instead of thinking about all these significance levels, right, and setting them up and pretending like that's a huge deal, you can just look at your test statistic and just know kind of that, like 2.04, in my mind, I know that's pretty good. I would probably reject. Anything beyond 2 is pretty significant, but there are significance levels where you wouldn't reject it. So it's really nice to have a z-score that's higher than that. Oftentimes, a z-score can be beyond 3 standard deviations. Okay, if the true mean, you know, is really bigger than the hypothesized mean, and it's a lot bigger, then this z-score could be quite large, and that really gives you evidence. That gives you more than enough evidence to reject at any significance level. Okay, none of the significance levels have z-scores beyond 3. So what you can do is you can just look at this and just in your mind say, oh, that test statistic is pretty extreme. It's pretty far out there, pretty far above. And so I would probably reject it here at a lot of the significance levels, but you know, there is those critical values that are above 2.04. I wouldn't reject it at those significance levels. Okay? So that's a way of thinking about this, just looking at your z-score and noting how big it is. And if it's really high, like beyond 3 standard deviations, you'd have enough evidence to reject. Okay? So now the type 2 error, this is, of course, not concluding the sharks are longer when in fact they really are. So you're accepting H0, right? But you should have rejected H0 and concluded that they were longer. Well, we don't know the probability of committing the type 2 error because it actually depends upon the difference between the true mean and the hypothesized mean. Sorry, my son is not happy about something up there, but I'm going to try to keep going on, try to concentrate. Okay, because this is going pretty good here. Okay. So the probability of this is unknown because it actually depends on the difference between the true mean and the hypothesized mean. Okay? And we don't know that. We don't know the true mean. Okay? So the way to understand this, in this particular example, okay, this is concluding the sharks. This is not concluding the sharks are longer when they really are. So the probability depends on how much longer the sharks really are. So in other words, if the difference is big, like this mu naught, I put mu with a little 0 subscript, we're going to say that's the hypothesized mean. So if the sharks are 21 feet here, or if we hypothesize that they're 20, if the hypothesized mean is that they're 21 feet, let's say the true mean is that they're 50 feet. Okay? Well, you're probably going to catch that. Okay? You're not going to commit the type 2 error and say that they're, and not conclude that they're longer. So if the difference is really big, like this, then there's a very small chance that you're going to commit the type 2 error. Okay? But let's say the shark is only like 22 feet long, and the difference is not very big. Well, there's probably a pretty good chance you'll commit the type 2 error. So I have here, if the difference is small, then you are less likely to catch it, and then there's a higher probability that you'll commit the type 2 error. Okay? And so, but in a sense, that kind of works itself out, because if the difference is only a little bit, okay, you might not catch it, but then again, the difference isn't that big, so it's not as big of a deal if you don't catch it. Okay? And so in a sense, that kind of works itself out. When the difference is large and it's important that you catch it, you usually will. The probability of committing the type 2 error is very small. Okay? So even though we don't know the probability of that, there is a sense in which it kind of works itself out. Okay? There's also, and I didn't write this down here, there's also, it's also known that if you increase your sample size, then you're less likely to commit the type 2 error. So increasing the sample size also decreases the chance of committing the type 2 error. Okay? So that's kind of the idea behind this. So let's actually look at a couple examples of how I might think about this when I'm analyzing the results of an experimental study. So let me see if I can zoom in. This is the very first hypothesis test I did at the beginning of the lesson. Remember, we're trying to decide if the company was meeting their claims. So they said that we assumed that they were filling up bags of chips, and they were claiming that it was 13.5 ounces. Okay. This is that test. So we assume that their claims were true. The null hypothesis says there is no difference, that it is 13.5 ounces. So that's the hypothesized mean. And the null just says the true mean is equal to the hypothesized mean. But we wanted to see if maybe the true mean was less than that. The company was not meeting their claims. And we performed it at the 0.05 significance level, and that gave me this critical value, negative 1.645. And if I was less than that, then I rejected H0. Well, when I calculated my test statistic, I got negative 3.46, which was in the rejection region, okay? And so I rejected H naught, and there was enough evidence to conclude the true mean is less than 13.5 ounces. Okay. Now, first of all, I want to show you. Let's see if we can figure out what the type 1 and type 2 errors are. Okay. So in this test, the type 1 error would be rejecting H naught and concluding that the true mean is less than 13.5 ounces. When in fact they're not. Okay, so this would be concluding true mean is less than claimed, because 13.5 ounces was the claim, when in fact it's not. Okay, in a sense, this is kind of saying the company is guilty, concluding that it's less than, when in fact it's not less than. The company's claims were being met, and we in a sense condemned them and said that they were guilty when in fact they weren't. That would be the type 1 error. The type 2 error here would be accepting H naught when really H naught is false. So this would be not concluding the true mean is less than 13.5 ounces when in fact it is. Okay, so maybe I can zoom out just a little bit here. Ooh. Okay, so the type 2 error would be not concluding the true mean is less than 13.5 ounces when in fact it is. Okay, so this would be in a sense acquitting the guilty. The company was really guilty, but we didn't find them guilty, and so that would be the type 2 error. That's the way you could think of that. So when I perform this test and I reject H naught, which of these two errors do I run the risk of committing? Okay, and the answer is the type 1 error, because the type 1 error, I'm rejecting H naught. Okay, but if H naught is actually true, then I'd be committing the type 1 error. So if I'm concluding the true mean is less than claimed when it's really not, then that would be the type 1 error. Okay, so what is the probability then? So I run the risk of committing that, but it doesn't mean I'm committing that error, right? So what's the probability of me committing the error? Well, in this case, my alpha level was 0.05, so I'd have a 5% chance of committing the type 1 error in this case. But this z-score is beyond 3 standard deviations, so I could still reject it at the 0.01 significance level, right? In fact, I could reject it at all significance levels, and in fact, this is so extreme, so far below, that you would never expect that to happen. It would be very, very unusual. So in a sense, I don't have to worry about committing the type 1 error. So really the right decision to make, anytime this is beyond 3 standard deviations, the right decision to make is to reject H naught, okay? And you are almost certainly making the right decision. So that's how you would interpret this test, okay? These would be the two possible errors. You run the risk of committing the type 1 error, but in this case, you don't have to worry about that because it's so far below, so far into the rejection region that it's very clear that the true mean is less than what the company claimed. In a sense, we caught the company red-handed. Okay, the numbers give you good, very, very strong evidence to conclude. Okay, that's kind of the idea. So let's look at the second one. And so this was the second example that we did. This was when we were asking whether the class size had changed. Okay, so 5 years ago, the average class size was 24, and so that's our hypothesized mean. And so we're assuming the null hypothesis assumes that there is no difference. The true mean is equal to 24, and then we wanted to see if we could reject that in favor of that there is a difference. Okay, that the true mean is different than 24. And we performed this at the 0.01 significance level. And so my critical values down here ended up being negative 2.576 and positive 2.576. So if you were less than that, you would reject. If you were more than that, you would reject. Okay? Now notice these are really significant. Okay? Critical values. It's requiring a lot of evidence before you would reject. Okay? And our test statistic here is 2.25, which actually was not enough evidence to reject. So I would fail to reject H0. And that means there was not enough evidence to conclude that the true mean is different than 24. Okay, we're going to analyze this here in a second, but first let's write down the two types of errors. So the type 1 error would be rejecting H0 in favor of the alternative when really H0 was true, right? So this would be concluding class size is different when in fact it is not. Or I should say, concluding that the class size has changed when in fact it has not changed. So that would be the type 1 error, rejecting H0 when H0 is true. The type 2 error would be accepting H0 when H0 is false. So this would be not concluding class size. And I should be saying that the true mean class size, okay, not concluding the class size is different when in fact it is different. Okay? That would be what the type 2 error would be. So, when I actually perform the test and I fail to reject H0, okay, and I conclude there is not enough evidence to conclude the true mean is different than 24, then which of the two errors do I run the risk of committing? Okay? Well, I run the risk of committing the type 2 error in this case. So whenever you fail to reject H0, you're running the risk of committing that type 2 error. Doesn't mean you're necessarily committing it, but you run the risk of committing it. Now, we don't know the probability of that, right? And the reason for that is the probability of committing the type 2 error depends on how big the difference is, right? So if the class size was like 50, you know, or the class size was like 5 students, like if it changed dramatically from 24 one way or the other, we're going to catch it. Okay, you're going to see it. There'd be a very, very small chance of committing the type 2 error, right? But if it's only a small class size, like if it was 23 students or 25 students, and it only changed a little bit, then there's a pretty good chance you might be making the type 2 error. But do you see how that kind of works itself out, in a sense? Because if it changes dramatically, you'll catch it. But if it's only a small change, then you probably won't catch it. But then it's only a small change. It's not as big of a deal. Okay? So in fact, with that sort of z-score, let's think about it. At the 0.05 significance level, my critical values here would have been negative 1.960 and positive 1.960. So at the 0.05 significance level, I did have enough evidence to reject. Okay? So it's just at the 0.01 significance level required more evidence, and so I didn't have enough evidence to reject it at this significance level. But at the 0.05 significance level, I did have enough evidence to reject it. Okay? So a way of thinking about this is when you have a z-score like this, which is above 2 standard deviations, but not quite enough to reject it at your significance level, chances are that the true class size really is a little bit larger, okay? But it maybe isn't that much larger. It's just maybe a little bit larger, and it wasn't enough to conclude it at the 0.01 significance level. That's probably what's really going on. So this is where being able to look at the actual value of this test statistic and kind of weigh it and say, you know, it's not huge. You know, something like this is really nice because then you'll catch it for sure, right? And it's not like that. You know, it's in that iffy range. If it was beyond, you know, 3 standard deviations, then I'd know for sure. But it probably is larger. With a test statistic like that, the class size probably is larger. And so oftentimes what people will say is that the difference, if there is a difference, it's not a statistically significant difference, at least not at the 0.01 significance level. So given this significance level, which is a pretty high significance level, the difference, if it exists, is not a statistically significant difference. And then that really helps you kind of see that, okay, it probably is a little bit different, you know, but it's not a statistically significant difference at that significance level. Okay? But at the 0.05 significance level, we could say that we have a statistically significant difference. Okay? But it would be at the 0.05 significance level. And so those significance levels, the 0.01 is requiring more evidence before it would be statistically significant. Okay? So that's what's going on. To whatever degree you understand the 2 possible errors you could be making and how these relate to those and the probabilities, to that extent you're going to be able to really use the results of your test to make a wise choice. Okay? So when you actually make a conclusion, it's not guaranteed. It's not 2 + 2 is equal to 4, and that's guaranteed 100%, right? You're drawing a conclusion, but what you're doing is you're weighing evidence. You're requiring a certain amount. Your significance level is requiring a certain amount, and when you conclude, you could be making an error. Whatever you conclude, it could be one of these 2 types of errors. Okay? So that's what's going on with that type 1, type 2 error. So I don't even think there's any problems on the homework dealing with the type 1, type 2 errors. When I went to search for ones involving type 1, type 2 errors, the Connect Math that I'm using at the moment did not even have any questions. That kind of disappointed me because I think there should be at least a few questions about type 1, type 2 errors. But hopefully you were able to understand this, and to whatever degree you did, I think you have a better understanding of what you're really doing with these hypothesis tests.